Hi, this is Jack from Maths Forge, and in today's lesson, we're going to be doing special sequences. So there are 4 special sequences that you need to be aware of. The first one is square numbers. Now, the square numbers, you can get to them by taking the natural numbers, 1, 2, 3, 4, and so on, and squaring them. If we do this, we get the first square number of 1, because of course 1 times 1 is 1. The second square number is 4, because 2 times 2 is 4. The third square number is 9, because 3 times 3 is 9. And the fourth one is 16. Now, if you're dealing with a sequence that has square numbers, you can identify this by trying to square root the terms in your sequence. If you square root a term in the sequence and you end up getting a whole number, then the chances are that you are dealing with the square numbers. Now, another special sequence is the cube numbers. And just like the square numbers, the cube numbers, you can get to them by taking your natural numbers, 1, 2, 3, 4, and so on, and cubing them. And of course, 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. And 4 cubed is 64. You can identify whether you're dealing with the cube numbers or not by trying to cube root your terms. So if I had, for example, 125, if I was to cube root this, I would end up with 5. You could try doing this to a few more terms, and if you keep getting whole numbers, then you are dealing with the cube numbers. Another special sequence is the triangular numbers, and the triangular numbers is an interesting sequence. We start with 1 dot, which is 1, and then we do 2 other dots, which make a little triangle here. And then there are 3 dots now. And then we add 1 dot to the column and 1 dot to the row from the previous term. This now gives us a triangle with 6 dots in total. And we'll do this one more time. So now we're going to have 4 dots for the height and 4 dots for the base. Now we have 10 dots in total. So if you're dealing with triangular numbers and they're pretty large, here's how you can identify them. From one triangular number to the next, the term-to-term rule increases by 1 each time. So to go from 1 to 3, we add 2. To go from 3 to 6, we add 3. And to go from 6 to 10, we add 4. As you can see, the term-to-term rule is changing by +1 each time. And this is how you can identify that you're dealing with the triangular numbers. The final special sequence we're doing is going to be the Fibonacci sequence. Now, the Fibonacci sequence is a very special sequence. You can see this sequence of numbers in many different areas of nature. The Fibonacci sequence is achieved by starting off with 1 and then another 1 and then using the 2 previous terms to get to your next term. So the next term is going to be 2, and then we'll use the 2 previous terms, which is 1 and 2 now, to get to the next term, which is 3. And the 2 previous terms now to get to the next term, which is 5, and so on and so forth. So how you can identify if you're dealing with the Fibonacci sequence is take your previous 2 terms, add them together, and see if they give you the next term. If this is the case, then you're probably dealing with the Fibonacci sequence. So the 4 special sequences were square numbers, cube numbers, triangular numbers, and the Fibonacci sequence. We're now going to attempt 1, 2, and 3-star questions for the lesson on special sequences. So let's take a look at this 1-star example. Here we're being asked to name the sequence. I can see straight away that if I add 8 to 13, I get 21. So I'm going to say that this is the Fibonacci sequence. And if we check our answer, there it is. We can also call it the Fibonacci numbers. Let's take a look at another 1-star example. Here we have 4, 9, 16. I know from practice that these are the square numbers, and we can test this out. The square root of 4 gives us 2. The square root of 9 gives us 3. The square root of 16 gives us 4. As you can see, square rooting all of the terms in this sequence gives us whole numbers, and therefore we are dealing with the square numbers. And if we check our answer, there it is. Another 1-star example with slightly larger numbers. I'm thinking about my special sequences now, and just going through all the possibilities in my head, I can see that if we add 200 to 300, we get 500. 30 to 70, we get another 100, which makes the total 600, and 3 plus 7, which is 10. So the total now becomes 610. So if I add these 2 together, it gets me the next term. This is the Fibonacci numbers. And if we check our answer, There it is. We'll do one more one-star example. Here, I can see straight away that it's definitely not the Fibonacci numbers. It's also not the square numbers either, as the only square number here is 36. Neither is it the cube numbers, as none of these numbers are cubes. So this must be the triangular numbers, and we can test to see if this is true. From 36 to 45, we add 9. From 45 to 55, we add 10. So you can see the term-to-term rule is increasing by 1 each time. This is definitely the triangular numbers. And if we check our answer, there it is. Now let's do a 2-star example. Here we can see that this is the Fibonacci numbers. If I add 5 and 8, the two previous terms, to 13, we get 13. So in order to get to the next term, we have to add 8 and 13 together, which gives us 21. And if we check our answer, there it is. We'll do another 2-star example. I can see straight away that we're dealing with the square numbers. If I square root each number, I will get whole numbers. And therefore, we are definitely dealing with the square numbers. So the next square number here, I can actually work backwards for this. I can take 5, which is going to be the next term in this sequence here, square it, and this will give me the next square number in the sequence, which is 25. So if we check our answer, there it is. We'll do another 2-star example. Here, I can see straight away that it is not the Fibonacci numbers, as if I add 121 and 144, we do not get 169. I know that it's not the cube numbers, because if I try and cube root 121, I end up with a decimal. We can check to see if it's the triangular numbers. To go from 121 to 144, we add 23. And from 144 to 169, we add 25. This is definitely not the triangular numbers. As the triangular numbers, the term-to-term rule goes up by 1 each time. In this case, it's gone up by 2. So the final special sequence that we haven't mentioned is the square numbers. If I square root 121, I get 11. If I square root 144, I get 12. And if I square root 169, I get 13. So we are definitely dealing with the square numbers. To get the next term in this sequence, I'm going to take 14, the number that comes after 13, and square it. This now gives us 196, which is what I think the next term in this sequence is. And if we check our answer, there it is. Now we'll do a 3-star example. I can see straight away here that 144 is a square number. This is 12 squared. Now we can see if 169 is also a square number. We can take it, square root it, and if we get a whole number, we are dealing with square numbers. This indeed does give us 13, and we'll try this with 196 as well. This gives us 14, so we are definitely dealing with the square numbers. The number before 12 is 11, and if we square this, we should get the previous number in the sequence, which is going to be 121. And if we check our answer, there it is. We will do another 3-star example. Here I can see that we're definitely not dealing with square numbers, as none of these numbers are square numbers, nor are they cube numbers. So it's either the Fibonacci sequence or triangular numbers. If I test to see whether they're triangular numbers or not, from 34 to 55, we add 11. And from 55 to 89, we add 34. So this is definitely not the triangular numbers. This must be the Fibonacci sequence. And we can test to see if this is true. 34 plus 35 does indeed give us 89. So how we can find the previous term in the Fibonacci sequence is by thinking about how we get to the next term. So we have this term here that we're looking for. We're going to say it's a question mark. And when we add it to 34, so the two previous terms, it gives us 55. So rearranging this to find out what this question mark is, if it's plus 34 on this side, then it's going to be minus 34 on this side from balancing equations. And therefore, the missing term in this sequence must be 21. And if we check our answer, there it is. And that's it for the lesson on special sequences.